Today we'll start function. That's what the topic is about, functions, and these what we'll cover: modular programming, defining and calling functions, function prototypes, sending data into a function, passing data by value, the return statement, return a value from a function, and returning a Boolean value. Using functions in menu-driven program, local and global variable, static local variable, default arguments, using reference variables as parameters, overloading functions, the exit function, the stop time drivers. So modular programming, it's basically breaking a program up into smaller manageable functions or modules, supports the divide and conquer approach to solving problem. Now this modular programming, if you have taken the Python class, we went over with subcharts. Do you remember that? In the flowchart, you will go to main, you right click and you click on subcharts. And then you broke the program that you had into pieces. So in your main program, all you had was just the calling of the functions. So, and it's clean, it's organized. So this is the whole idea of modular programming. So a function is a collection of statements to perform a specific task. You may hear the word subchart, you may hear the word modular or module, or you may hear the word function. So they mean pretty much the same. And even when you come to Java, you will hear methods, which is pretty much the same concept. So motivation for modular programming simplifies the process of writing programs, improves maintainability of programs. A function call is a statement that causes a function to execute, and a function definition is the statements that make up a function. So the definition includes the name of the function. Function names follow same rules as variable names. Parameter list variables that hold the values passed to the function. In math, how is a function written? F of x, right? So you have the f and then you have what? After the f you have what? Parentheses, right? And then you have the x, right? And then close parentheses. So the f you have, and then the parameter list is the x. Does that make sense? It says the parameter variables that hold the values passed to the function, f of x. And if you reached second calculus, like the end of calculus, you learn f of x comma y, right? So you can pass two parameters. So in the beginning, when you're in just college algebra and so forth, you just learn f of x. But then again, once you reach I think it's the last chapter that's covered in there, it's f of x, comma, y, and it can be comma, z, and so forth. So that is what the parameter list is. You're passing more than one variable. The body of statement that performs the function's task, the return type, data type of the value of the function returns to the part of the program that called it. Is it an integer function? Is it a void function? Is it what do you call a float function and so forth? So normally in the driver of the main of the C++ function, we have it as int main. Java, you see it as void and so forth. Okay, void main and so forth. Okay, so this is the return type. That's the name of the function. So these are where the parameter list is. This one is empty right now, and then you have the body. So the function header consists of the function return type, the function name, the function parameter list, and then example. So note there is no semicolon at the end of the header. If a function returns a value, the type of the function must be indicated, int main. If a function doesn't return a value, its return type is void. So void print heading, cout, monthly sales. Calling a function, so to call a function, use the function name followed by the parentheses and the semicolon. So when a function is called, the program executes the body of the function. After the function terminates, execution resumes in the calling module at the point of call. Main is automatically called when the program starts. So main is another name for it, it's like the driver, okay? Because everything is called there. So function can call other functions. So the compiler must know the following about the function before it's called: the name, the return type, the number of parameters, and the data type of each parameter. Ways to notify the compiler about a function before a call to the function. So place function definition before calling a function's definition, and then you can use a function prototype similar to the heading of the function. So here you have the heading and the prototype. So function prototype is also called a function declaration. Prototype notes, place prototypes near the top of a program. Program must include either prototype or a full function definition before any call to the function, otherwise a compiler error occurs. When using prototypes, function definitions can be placed in any order in the source file. Traditionally, main is placed first. So can pass values into a function at a time of call. So these are some of the built-in functions like a square root that you can use. Value passed to a function are arguments. Variables in function that hold values passed as arguments are parameters, like f of x, f of xy. Those are called parameters. Alternative names is arguments, actual parameter. So the parameter is a formal argument or formal parameter. For each function argument, the prototype must include the data type of each parameter in its list. Okay. So the heading must include the declaration with the variable type and name for each parameter list, a parameter in its parentheses. So the function call for the above function would look like this. So note the argument in the call. Value of argument is copied into the parameter when function is called. Function can have more than one parameter. So we said instead of f of x, you can have f of x comma y. There must be a data type listed in the prototype and an argument declaration in the function heading for each parameter. Arguments will be promoted, demoted as necessary to match parameters. Be careful here. So when calling a function with multiple arguments, the number of arguments in the call must match the number of function prototypes and definition. We'll see an example. And then the first argument will be copied into the first parameter, the second argument into the second parameter, and so forth. So here's an example. So you have this display data, height, and weight, and then void display int, h int. So this will be the heading, and then the CR. Maybe we'll run this as an example when you have multiple arguments. Pass by value, this one, an argument is passed to a function. A copy of its value is placed in the parameter, and then the function cannot access the original argument. Changes to the parameter in the function do not affect the value of the argument in the calling function. Passing data to a parameter by value. So you have int value, and then even or odd, and then you pass that value in here. Okay. So an argument in the calling function, and then the num5 parameter in the even odd function. So this can change variable num, but it will have no effect on the variable. So used to end, the return is used to end the execution of a function and can be placed anywhere in a function statement that follows. The return statement will not be executed. It can be used to prevent abnormal termination of a program. So without a return statement, the function ends at its last. So return statements can be used to return a value from the function to the module that made the function call. So prototype and definition must indicate data type of return value, not what. Let's see. Calling function should use return value. Example, assign it to a variable, send it to a CF using an arithmetic computation, use it as an arithmetic computation and a relational expression. Again, use always when you see these pages that the after references. Return a value, the return statement, so format is a return and then whatever the expression is. It may be a variable, a literal value, and an expression. In the case of the main, we have seen was return 0 as a value. Or you can say return, and then you can do some calculation there, whatever A times B is if you had 2 values 0 passed. The expression should be of the same data type as the declaration return type of the function, and it will be converted if it's not. And you can return a Boolean value, true or false. Declare the return type in the function prototype and heading as a bool. So the function body must contain a return statement that returns true or false. So the calling function can use the return value in relational expression. Okay, an example of the Boolean type. So you can use functions in a menu-driven program. So to implement the user choices from a menu, to implement general-purpose tasks, higher-level functions can call general-purpose functions. This minimizes the total number of functions and speeds the program development time. So we have local and global variables. So local variable defined within a function or a block accessible only within the function or block. Other functions and blocks can define variables with the same name. When a function is called, local variables in the calling function are not accessible from within within the call function. This is called the scope. So let's say this room is a function, and the next room is a function. So if we define a local variable here and call it Mohammed, and we have it in this room, this local variable called Mohammed, we are the only ones that have access to it. They don't have access because it's a local variable. If they have their own local name variable called Mohammed, they have access to it. We don't have access to it. Okay, this is what's called the scope. Scope means the accessibility. Do we have access to it? You know how somebody says it's outside of my scope? It means I don't have access to it. Okay, so that is what's called local variable. Now, if we have Mohammed variable named in the hallway. All right. If we look, we stand there, we are able to see it, so we have access to it. If they go outside and like you look at the window or at the door, they have that access that variable called Mohammed, because that one is what's called a global variable. Because it's global to both of us, we can access it. Does that make sense? However, the ones that are defined within each class is not global. We only see the one that is defined inside our function here or our classroom, right? So it's not outside of our scope for us to access it. We can access the ones. But now, can I create the same two variables, local variables, both of them named Mohammed, in the same function? No, it would be confusion. If I call Mohammed, it would be like, okay, me, which one is it? Mohammed 1 or Mohammed 2? So you have to separate it. Does that make sense? But you can have the same name on that function and the next function, because they're two different functions. So a local variable only exists while it's defining a function is executing. And they are destroyed when the function terminates. So data cannot be retained in a local variable between calls to the function in which they are defined. And global variable, we said, is defined outside of all functions. It's accessible to all functions within its scope, outside. Within its scope means within its accessibility. Okay. Easy way to share large amounts of data between functions. Scope of global variable is from its point of definition to the program end. Use is sparingly. So initializing it, local variables must be initialized by the programmer. Global variables are initialized to 0 or null. So when the variable is defined, so these can be overwritten with explicit initial values. So global variables make programs that are difficult to debug, functions that cannot be easily reused, and other programs that are hard to understand. Then you have what's called global constants, where you can set things that are constants that don't change, like a tax rate, some fee that doesn't change, stuff like that. So it's a name constant that can be used by every function in a program. So if they are useful, if they are unchanging values that are used throughout the program, they are safer to use than global variables, since the value of a constant cannot be modified during a program execution. So local variables, we said, can have the same name as global variables. When a function contains a local variable that has the same name as the global variable is unavailable from within the function. So the local definition hides or shadows the global definition, okay? Because the local one overrides the global one. So the local only exists while the function is executing, and defined each time a function is called. And they use the content when the function terminates. And you can have static local variables. They are defined with the keyword static, okay, and are defined and initialized only the first time the function is executed, retaining their contents between function calls. You can pass values passed automatically if arguments are missing from the function call, and it must be a constant declared in prototype or a header. Right. So multiple parameter functions may have default arguments for some or all parameters. You have default arguments. If not all parameters to a function have default values, the ones without default must be declared first in the parameter list. And it gives you an example. When an argument is omitted from a function call, all arguments after it must also be omitted. Mechanism that allows a function to work with the original argument from a function call, not a copy of the argument. So allows the function to modify values stored in the calling environment. Provides a way for the function to return more than one value. You have reference variables. It's an alias for another variable. It's defined with an ampersand in the prototype and in the header. Changes to the reference variable are made the variable it's referenced to, so use reference variables to implement passing arguments by reference. And then an example, passing by reference. Okay, and then void. So each reference parameter must contain an ampersand, an argument passed to a reference parameter must be a variable. Let's see. It cannot be an expression or a constant used only when appropriate, such as when the function must input or change the values of the argument passed. Overloaded functions are two or more functions that have the same name but a different parameter list. Okay? And it can be used to create a function that performs the same task but takes different parameters type or different numbers of parameters. So compiler will determine which version of the function to call by the argument and parameter list. So for example, here, this one has one parameter, you have two different data types, two that are the same. So whichever that's executed, so for example, here you have, which one? So here you defined height, and so you have int and int, right? So it will execute the length and width that come from here, okay? So if it's get dimension double and double, so here we will use this. Okay. So the exit function terminates execution of a program, can be called from any function, and can pass a value to operating system to indicate the status of a program. Execution usually used for abnormal termination of program. It requires the CSTD library header file used with care. You can use an integer value to indicate a program status. Often 0 means successful completion, non-zero indicates a failure condition. And you can use named constants defined in the CSTD library. Exit success and exit failure. Stub is a dummy function in a place of an actual function. So usually displays a message indicating it was called. May also display parameters. You have the driver function that tests a function by calling it. Stubs and drivers are useful for testing and debugging program logic and design. So let's look at some of the examples we had, and maybe run it to give you an idea. This one we saw, right? We can copy this one and maybe try to run it. So this is the function, and if you're going to call it, we need to take this. So when you create a function, you need to call it inside the main. So we paste that here. Right? So here it says void display int h and int w heading, and then here is where we need display data height and weight. So here, if we say maybe int height and weight, maybe we can initialize it and say maybe int height equals 5 and weight equals 7, and then run this. It will give you height is 5 and weight is 7. So this was a function, right? There's no return type. We're not doing much to it other than just displaying, right? And then here we initialize it. Of course, you can ask the user to enter it, and then it's just making the call here. Display height and weight for me. Just a basic function. You can create another function that will just display hello world and then and call it as well. Let's say we create another function and call it um, void hello world or something like that. And then again, we defined, we created a function, and then when we call it here, we'll just say hello world, and then run it. That's all it will display. Right? Welcome to C++, and then hi. Of course, it's not formatted. You want to format it and do whatever you want to do, basically, right? Instead of saying hello world, you will just say maybe something like this program displays the height and weight that is initialized. Something like that. And then you have height. Of course, you can do whatever else, but this is basic, declaration of a function. A couple of functions here, and then we are making a call to those functions. All right.